Now let's start talking about the first type of attributes, which is instance attributes. Simply, instance attributes are the attributes that belong to the class instances, not to the class itself. So this is very important. To the class instances, not to the class itself. In other words, I can say each class instance or object has its own values for these attributes. So if you remind the example of bank account, one of the attributes is account holder name. And we know that for each instance of this bank account, for each object of this bank account, each object should have a different name from the other objects. So for example, John Smith for the first object, John Doe for the second object, and so on. Now let's learn how we can add instance attributes to our class. First of all, I will create the class itself, I'll give it a name, and then I will start to add these attributes one by one. But before talking about how we can add these attributes, let me tell you about this init method. First of all, this is a special method, and usually it's named $init_, and it's called a constructor method. We use this constructor method usually to list all the available instance attributes for my object and to give them initial value. This initial value could be passed from out of this method because at the end it's just a normal method like any other method, but it's called when we define an object from this class. Don't worry if you don't understand this idea right now because you will see it in action later on in the code session. But what I need you to know that in order to define instance attributes, usually we define a method, its name, init, it's called constructor, and in this constructor we list all the instance attributes. Also, you will note that the first parameter to this method, it's named self and its color blue. Self is not a reserved keyword. You can use any word you would like. But here in Python, it's a convention to use the word self. And self in this context means the object that I am defining in this moment. So, in Python, when we call the constructor method, the interpreter automatically will pass the object that we are defining into this method. So when I pass this object to this method, then I use self.instanceAttribute in order to add attribute to this object. So we are using the dot operator in order to attach attribute to an object. In this simple example here, I have two instance attributes, instance attr1 and instance attr2, and I choose to pass two values from the constructor in order to give them initial values. Now let's talk about instance methods. Simply, these methods are the methods that has access to the instance attributes. Usually, the first parameter of this method is always self, like the init that we see in the previous slide. And usually this self is automatically passed to the method, and we will see later on how we can call a method for an object. And this self represents the instance that call this method. We can understand from this that the instance method should have access to the instance attributes in order to be able to handle and process these attributes. And one very important point here to be mentioned is method overloading is not supported in Python. And method overloading is defining multiple methods with the same name but with different list of parameters. So if you are from a different language programming background and you are using method overloading in other languages, you have to know that in Python, method overloading is not supported. Now let's see how we can add instance methods into our class. First of all, we have to define our class, and as usual, the first method after the class name would be init or the constructor method, which we use usually to give values to the instance attributes. After that, I start to add the instance method one by one. Look, how I create this method, very simple. I create them as any normal function in Python. I use the keyword def, then I give this method a name. Then the first parameter is always self. Look, in instance method 1 and 2, the keyword is self. And it's not a reserved keyword. Be careful, it's just a convention. And after this, you can pass any type of argument you want to this method. So you can use positional argument or arbitrary arguments. Once we have defined our method, we can start to implement this method by writing some codes that actually has access to self. And when I say it has access to self, self has access to instance attributes. So I have access to instance attributes inside instance methods. And once I have the access, I can write any code I want to process and handle these attributes. Now to make everything clear, let's move to Jupyter Notebook in order to see some examples about these methods and these attributes. In the previous lecture, we defined a class for student, but it was an empty class. Now let's upgrade this class by adding some instance attributes and instance methods. First of all, let me create this class again. And the first thing that I'm going to talk about is init method. Init method is the constructor method, and usually we use it to define instance attributes and give initial values to these instance attributes. Now, before adding any instance attributes, let's see this constructor method in more details. If I say print, hi, I am a new object. And then let me define an object from this class. So let me say I have a new student, and I'll use the name of this class to define an object, and I'll run. Look here, I have this sentence printed here, which means that when I am defining an object from a class, automatically the constructor method is gonna to be called. So you will not call this by yourself, but the class will call init method in order to initialize the values. Now let me print the type of this self. Run. As you see here, the type is student, and we can understand from this that self is an object from the class student. And this is what I have mentioned before. I said when you define an object, automatically the object that we would like to initialize will be passed to the constructor method, which is init in this case. Now, let's upgrade this init method and let's add some instance attributes to this class. I will define my class again, which is student. Then I'll say def init self, and then I will define the first instance attribute, which is ID in this case. And I will give just initial value, which is null. Now, I have a class which has one instance attribute, which is ID in this case. Now, for the sake of time, I will copy and paste this. And here I have a class, its name student. And as you see here, for this student class, I have ID, first name, last name, initialized by empty strings. Then I have full name, which is first name plus last name with a space in between. I have age, and I have classes that this student enrolled in. So, very simple, easy to add instance attributes. Now let's see how we can define an object. Also, it's very simple process, same like here. I'll say new student equal to student. And now from this student, I will print what? I will print new student dot ID. And I will run. I get a name error. Why I get this name error? It says that first name is not defined. Look here, there is nothing first name. We have self.firstname. For this reason, I'll say self dot, and here I'll say self dot last name. Let me run again. You will see that I get here a new object, and then when I print student.id, I get none. Why none? Because the value is none. And we can understand from this that this attribute now becomes defined. Now, what if I say print student dot, let's say ID2, run? I'll get an error. Why error? Because this said that student object has no attribute ID2. And this is clear. I have only ID. There is no ID2. And from this, we can understand that in this way, now we are attaching some instance attributes to the objects of the type student. And look here, for all of these attributes, I use small letters to define these names, and I use underscore between two different words. And this is a convention when we want to define attributes. In this example, I have initialized all the values within the init method by values that I have chosen by myself, like none or empty string. So, how I can give the user the flexibility to pass the values that he wants when he wants to create an object from this class. Let's see how we can do that. First of all, I'll copy this because it's already here, and I will paste it here. And as we know, init is just a method. It has a special job to initialize variables or attributes, but at the end, it's a method. So I can pass some arguments to this method. So for example, I can say ID, first name, last name, age. So I'll not pass the full name because it's just a combination of first name and last name. And here ID, look, it's a green because it's a keyword. So I will make it underscore ID. So I'll replace all of these values by the values that I want to pass to this method, as you see here. Now, if I take this again in order to define an object and I run, I'll get an error. Why this error? Now look, init missing 4 required positional arguments, which is add, ID, first name, last name, and age. So we can understand from this now, we have to give our class some initial values to the attributes that we select here in this function. So I have to specify ID. So I can say 1 for the first name, let's say for example, Jacques. For the last name, let me say Ma. And for the age, let me say 25. If I run now, the code works and there is no error at all. So you can imagine that when you create an object, usually we use the name of the class. And here, just imagine that you are calling the init method. So what init takes here, you have to pass here after the class name. And beyond the scene, this student will call init and will pass these arguments to the init method. Now if I print all of this, like for example, student ID, student.fullname, I'll get Jackma. If I print the age, I'll get 25. And this is actually what I need. I want to give the user to specify the initial values of the attribute out of the class. So how to do that? Simply, we have to add some parameters to the init method according to our use case. Okay, great.